All right, we left off talking about the median in the last video, so we'll continue with the median right now. So we just discussed the indicator function, and now let's actually talk how that relates to the median. The median is the middle position in ordered data. It's the 50th percentile. So notationally, how we represent the median is with an X with a little swoopy thing over the top of it, which is called a tilde. This is read X tilde. So that's what the median is going to be used to, or what we're going to use to represent the median notationally. So going on to the next page here, we have some examples. I've actually modified this example from what you may see in your notes. I took one of the points out of it because I actually want it to be an odd number of data points. And then I'm also going to put it back in the purse snatcher data so that we have an example with an even number of data points. So first off, what we need to know is we need to know that these, how many data points there are. So let's first of all start with the fact that there are 1, 2, 3, 4, and 5 data points. So our n is equal to 5. So to find the position in the data that the median will hold, we're going to do the 50th percentile, so L sub 50, which is equal to the k, which is 50 over 100. Remember that this is also equal to a half or 0.5, whichever way you want to represent it. It doesn't really matter, so those things are both going to be equally as well represented. And then we're going to put in n here, which is 5. And then we're going to go ahead and do the multiplication. So half of 5 is 2.5. Now this falls under our second thing here, where fractions or decimals going to go up to the next position. So our L50 came out with a fraction or a decimal, so we're going to go up to the next position. So we're going to go up to 3. Now, even if this thing had been a 2.2, you would go up to 3. It's always up because we want to make sure that there's at least 50% below. So now that we have the 3, then we're going to say, okay, the third position in ordered data, see everything's in order, 1, 2, 3, and here we go. There's our third position. So we're going to write that X tilde is equal to, and that's 11.2, and I've said that these are minutes until service, so we're going to say 11.2, and then we're going to put the units, which are minutes here. And there we go. There's our median. So this is the indicator function that tells us where in the data we're going to locate that median, and here is the actual median. Okay, now let's go back to our favorite, the purse snatcher data. Now remember the purse snatcher data were years and ages, so these were all in order, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So our n for the purse snatcher data is 10. And we're going to put in 50 100s because we're still finding the median, the 50th percentile. And we're going to put in 10 here, and we're going to multiply. So half of 10 is 5. Now this lies under our first scenario. When it's a whole number, then we're going to use it and the next position in order to get the median. So we're going to use 5 and 6. So we're going to put this in, right, the 5th and the 6th to get our median. So now we're going to go that X tilde, and X tilde, the median, is going to be not 5 plus 6 and average it. You go and find the 5th and the 6th position. So 1, 2, 3, 4, 5, and 6. So these two are going to get averaged. So we have 29 plus 30, and then we'll divide it by 2. And so this gives us 29.5, and those are in years because the purse snatcher's data was in years. So that will be our median for the purse snatcher data. And now visually I want to show you what this represents. So the L sub 50, the indicator function, has helped us to mathematically find positions that measure where we're in the middle. So this 11.2 is right in the middle, right? It's the exact middle. There's 2 below and there's 2 above. And then this one, what we found by the average is we've found a position that's right here. Now, one of the things that you should get used to is a statistic doesn't always have an actual data point represented by that particular number. It can, but it doesn't necessarily have to be an exact data point. So this 29.5, which is right here in the middle of 29 and 30, has exactly 50% of the data below it. So that's what we're representing. That's the median. All right, now finally, we're going to go back and we're going to talk about the mean. Now we all know what a mean is. We all know that a mean is an average. So we may not have heard it called a mean before, but we all know what an average is. So a mean is an average. And an average is just meaning that we add everything up and we divide by the number of things we have. So in statistics, we have notation for the mean, and we have two different notations. We have sample statistic notations, right? So when we have a sample, then we're talking about a statistic, and we talked about that back in chapter 1. So a sample statistic, and the notation that we use for a sample statistic for the mean is x bar, and that's how we read that, x bar. And that is equal to the sum, and this is a Greek letter again. This is a capital sigma. So this capital sigma, I'm just going to put a cap and then sigma, means in math and science, sum things up. So this thing means that we're going to sum up values. And those x's are each of our data points. So when it says the sum of the x's, we're going to take each of the x's and we're going to add them up. So the first one plus the second one plus the third one plus the fourth one, so on and so forth. And then we divide by n. Now we all know what n is, right? N is the sample size. Now if we have a population, we have a parameter, right? So population, these things were parameters. And for parameters, we use Greek letters to represent parameters. And the Greek letter that we use to represent the parameter for the mean is this Greek letter. This one is the letter mu. And that's how it's pronounced, mu, is equal to, and it's exactly the same thing. We're going to add up all of the population x's, and we're going to divide it by the population size. Now when we have population, we use a capital N to represent the size, rather than the lowercase n that we use for our sample. So x bar is the sample mean, and mu is the population mean. And now we're going to go ahead and we're going to calculate the mean and the per snatcher data, and we're going to represent it as x bar because indeed it is the mean of the of a sample, because these per snatcher data, or this per snatcher data, is a sample. It is not the population. You know that it is not a population because that couldn't possibly be every per snatcher ever arrested age, right? There's only 10 of them. So I'm going to go ahead and do this using my calculator because I don't want to, just have it in my, have to add up every single value. But when I do this, I am going to expect for you to show me what you're doing. So first of all, notation, x bar is equal to, and we're going to do the sum of the x's, and that's divided by n. So what I'm going to be doing is I'm going to be adding 16 plus 17 plus, and then I'm going to go all the way out to that 50-year-old purse snatcher, and I'm going to divide it by my sample size, which there were 10 of these purse snatchers, and then I'm going to show what the sum of all of these was divided by 10, and then I'm going to finally get my average. Okay, so once we have all of these added up, the 16 through the 50, then we put it in. Now I've written down here at the bottom the instructions for actually doing this with your calculator. Once you have data entered into your register, then you're going to hit the stat key, then you're going to move over to the calculate menu, and then with the one variable statistics highlighted, which you will once you're in the calculate menu, then you're going to hit the enter key. Then you're going to do the second function key, and then you're going to hit the register number that you're in. Mine is in register 1, so register 1 is what I'm going to hit. So second function, the number 1. Then I'm going to hit return, and then I'm going to find, and what I'm going to find is not L1. What I'm going to find here is actually the sum of the x's, and that will be the second thing listed. And the sum of the x's for this data set is 298. Yes, 298. And then I'm going to divide that by 10, and then I'm going to write it down. Now your calculator, the first thing listed is actually x bar, and I don't want you to write just the x bar based upon the say, oh, it tells me what the mean is, I'll just write it down. I actually do want to see all of this work when you're in my class. And so we have 29.8 years, and that is the mean of the purse snatcher data. So that's as simple as it is. Now, depending upon whether we have a sample or a population, we'll be calculating the values. Now, this data here represents a population, because in the Carlton district, there are only 6 buses maybe. And if this is all the buses in the district, then that is the actual actual population. So we'd calculate a mean for the population, mu, rather than an x bar in that case. I'm not actually going to do that example. If you want to go ahead and try it on your own and see what you get, then you're welcome to do that one on your own. So now we're going to go down and we're going to talk about our next thing, which is the mid-range. So the mid-range is not very important, and it's just looking at the symmetry, because it can be looked at as, okay, here's the middle of the data compared to what we have for the exact middle position and what we've calculated for the mean. But we're not really looking at that very deeply. So I would like to begin talking about a frequency table and how to find the means from a frequency table. Now this one is something that I don't often put on a test or anything, but there's a great relation to this when we start talking about probabilities. And so that's why I want you to have seen how to find a mean based upon a frequency table. And then it also relates back to our Chapter 2 material and finding the midpoints of a class. So it's a good connection to a previous chapter and to a future chapter. So I'm going to end here and start another video after this.